before 1:30, but I was wrong. So another thing I wanted to let you know about, I'm thinking about doing a cooking live stream, so let me know if you're interested in viewing the cooking live stream, and I will try to oblige you this afternoon. All right. So, hello, Ethan, Obi, Will, Nathan, Scorched Ice. I don't even know who Scorched Ice is. Who is Scorched Ice? All right. So what we were talking about yesterday is this circuit. So we're talking about this circuit here, where we have a battery that's not connected to anything. It's just short-circuited. We would say the battery is short-circuited. Yesterday, we talked about the fact that wires actually have resistance. And so this would actually limit the amount of current that flows through the battery. But it turns out that there's another limiting factor on the current, which is the battery itself. So batteries have a chemical reaction that's taking place inside them, and that chemical reaction, the speed at which it takes place, determines how much current can come out of the battery. So you're limited by the battery chemistry. So I'm going to define a term. So an ideal battery is one that can output infinity amps. Okay? So an ideal battery is what we've been dealing with throughout the course so far. Is just one that is perfect. It can do whatever we need it to do. It can output infinity amps. Okay? A real battery cannot output infinity amps. Okay? So I'm going to give you a model of a real battery. So a real battery can be modeled like this. Okay, so everything inside this dashed box is a real battery. So a real battery behaves like a ideal battery in series with a resistor. Okay, so this resistance right here is what limits the current that flows out of the battery. Now, if you were to take a battery and crack it open and look inside, is there going to be a resistor? No. This is a model of how the battery behaves. So it's a functional model for doing calculations with a real battery. So, you know, this isn't what you would actually see, but it's how the battery behaves. So a real battery has an ideal battery inside it, and the voltage of the battery is called its EMF, which stands for electromotive force. okay? And it's called the internal resistance because it's the resistance inside the battery, and it's denoted by little r, okay? So this is our model of a real battery. So what if we had a real battery? Let's just do a little example. What if we had a real battery that we short-circuited? Okay. A pretty typical value for the internal resistance is maybe 1 ohm. Okay. So little r equals 1 ohm. And let's say that the EMF of this real battery is 6 volts. How much current are we going to get if we short circuit the battery? Okay. And how much current are we going to get? And we're even going to neglect the resistance of the wires. Okay. So if I used Ohm's law, I equals V over R, we can think about this circuit as just a single battery and a single resistor. So the volts that are being provided to the circuit is just the EMF, which is 6. Okay. And then the resistance is just the resistance of the internal resistance of the battery, which is 1. So we would get 6 amps. So what that means is that for this particular battery, real battery, the most current you could possibly get under the best circumstances is 6 amps. You're never going to get more than 6 amps from this battery. Okay. Notice that the less the internal resistance is, the more current you can get if you short circuit the battery. So, for example, car batteries have incredibly low internal resistance, and so that means that the car battery can really output current. So let's do an example. Okay. So let's suppose we have a real battery that's in series with a resistor. Okay. So let's suppose that this right here is a real battery of EMF let's say the EMF is 9 volts. Okay. And it has internal resistance 0.5 ohms. Okay. And say that we hooked that up. So we have the real battery of EMF 9 volts and internal resistance 0.5 ohms. We hook it up to an 8 ohm battery. So what I'm going to do is I'm going to redraw the circuit, but this time I'm going to draw the internal resistance explicitly. Okay? So the battery, the real battery is really a 9 volt battery in series with a 0.5 ohm resistor. Okay? And then that is connected to an 8 ohm resistor. Okay? So if I want to figure out how much current is going to flow, I would do Ohm's law, V over R. The voltage is 9 volts, and the total resistance of this circuit is so the total resistance of this circuit is the 8 ohms of the external resistance, we would call that the external resistance, and 0.5 ohms of internal resistance. They're in series. That's a total of 8.5 ohms. Okay? Battery, we're basically ignoring the internal resistance. And so in that case, we would have 9 over the resistance. If we're neglecting the internal resistance, then you only have the external resistance, which is 8 ohms. So we have 9 over 8, which is 1.13 amps. So you can see, so basically the conclusion here is that real batteries will output less current. Okay? So real batteries are not as good as ideal batteries, predictably. There's one other thing I wanted to show you. There's something called the terminal voltage, which is the voltage that the external resistance gets. Okay? The terminal voltage is the voltage that the external resistance gets. So in this case, the 8 ohm resistor. The observant student will realize that this circuit is actually a voltage divider with an 8 ohm resistor and a 0.5 ohm resistor. So if I calculate the terminal voltage, it's going to be the current that flows in the circuit times the resistance. So it's just Ohm's law. The amount of current that flows in this circuit is 1.06 amps. And it's all the same current because it's a series circuit and SIPOV. So because SIPOV, it's 1.06 amps. And then the resistance, the internal resistance is 8 ohms. Or the external resistance is 8 ohms, excuse me. So I would get that the resistance is 8 ohms, because I'm talking about the external resistance here. And that gives 8.48 volts is the terminal voltage. Notice that the terminal voltage is less than the EMF of the battery. The EMF of the battery was 9 volts. Okay? So we can make a conclusion based on this. Real batteries will output less voltage as well. So basically, a real battery is one that is not going to output as much voltage as you want it to, and it's not going to output as much current. Okay? So, it's kind of like real life is tough, all right? It's you're not going to get as much out of the battery as you would from an ideal battery. An important question, and then this will be the last comment, is when can we neglect the internal resistance of the battery? Because up to this point, I haven't even said anything about the internal resistance of the battery. So when can we neglect it? And you can neglect the internal resistance when the internal resistance is less, much less than the external resistance. Okay? So if the internal resistance is much less than the external resistance, you can just neglect it and you can treat it like it's an ideal battery. Okay? So going here, is 0.5 much less than 8? It is less than 8, but I wouldn't say that it's much less than 8, so I probably wouldn't neglect it in that case. But if this were like 800 ohms or something, 800 compared to 0.5, that's much greater. 800 is much greater than 0.5, so you could neglect the internal resistance in that case. All right, so that's all I have. Maybe I will see you on the Discord later, and maybe I will see you in the cooking live stream.